All right, so this is covering chapter 1 from your textbook, and it's just going to be our introduction to some basic statistical terms, some concepts about design and sampling, and a little bit about what you can prepare for as far as statistical notation. We'll introduce a couple of our basic level notation in this class as well. So, introduction, here we go. Statistics is a science that involves collecting, organizing, analyzing, and interpreting data. So, basically, anything that has to do with data can be called a statistical endeavor. There are different types of statistics, and most importantly, there is no science in modernity that operates without the application of statistics. So, if there's anything that you think science has done that is cool, I guarantee you that behind that thing that you think you know, there was statistical analysis. Whether you're talking about the discovery of the Higgs boson at CERN's super collider and experimental physics work, or if you're talking about determining the normal distributions of health statistics such as blood pressure, or you're talking about the probability of having some disease or the distribution of mental health, all of these things that we study scientifically are done using statistics. So statistics is everywhere. It's not just in science nowadays. When you think about your phone, right, Google Maps and all the other Google tracking, it's using all this enormous amount of crowdsourced data to be able to make predictions about when you will arrive at your destination when you're driving, to know what you might want to read next. Amazon knowing what products to recommend, Facebook knowing what things you might want to see on your feed. Even nowadays, something we all think about, actually, you're doing these kinds of recordings, right? The noise canceling technology, for example, Google, with their Google Meet video stuff, you had a guy develop a machine learning algorithm to identify and filter out waves that were noise and not voice statistics. I promise that in modernity, there is nothing that you take for granted that does not actually use statistics somewhere. So statistics can be applied and is applied all over. It has been used in enormously beneficial ways. It has been involved in driving forward society in everything from medicine to agriculture, from mental health practice to library science. And so you may not be a person who thinks you love statistics or are going to continue to do it or use it, but I promise you will continue to be exposed to statistics, and they are worthwhile to understand because they inundate our lives even if we don't understand them. So it's worth having some basic statistical knowledge, and that's what this course aims to provide. So statistics is all about data. So what's data? Well, data is just, hey, guess what? There is information, right? So you take for granted that actually your brain is a statistical engine. There's a great video. I'll post this video actually. A researcher at MIT, Laura Schulz, who does work with babies. And in this video, she does this great job of showing that babies have some concept, babies like 18 months old, some concept of what is a probable random sample, right? So it's this cool study. And basically, they've got this bin of balls in front of them. Some balls are yellow, some balls are blue. In one condition, most of the balls are yellow. In the other condition, most of the balls are blue. A researcher goes in to pull out a ball, and if the balls are mostly blue and the researcher pulls out a yellow ball, right, the children end up being, if they get like 3 yellow balls in a row, the children don't end up expecting the characteristics of those balls to generalize to the blue ones. And I don't want to give too much detail because you should watch the video, which I'll post, this TED Talk. But it's just amazing to show that your brain is not knowing what's there. Your brain is making predictions, right? Your brain is constantly taking in information to make predictions. That is what it does. And so, in fact, your brain is the first statistical, computation engine. Nowadays, we build computers that do it. But you take in information, you use that information to make best decisions based on the evidence. Now, the thing is, our brains don't always weight evidence fairly, correctly, in an unbiased fashion. In fact, there are so many biases, fallacies, and cognitive heuristics involved in human decision making that it's kind of surprising how awry it can go. I often do some demos when we do face-to-face lectures of some of these things. It doesn't work out quite the same way, unfortunately, with recording. But I promise, if you just do a little research about biases like the availability heuristic, like confirmation bias, like cherry picking, right? All of these things are great examples of how we make poor decisions when we try to make these predictions just using our brain. So this information's out there, our brain takes it in, it tries to make best guesses. Statistics simply tries to systematize the process by which information leads to decisions. So information is collected, is coalesced, aggregated, right, and collated into data. And so data then becomes this thing that can be analyzed with a particular procedure, right, using statistics, so that the process is now no longer opaque as the processes inside of our head often are. So I promise you're already doing it, you just don't realize it. And the thing is, statistics is just direct about its limits and about its processes in a way that we can't be inside of our own head. And that's why evidence-based decision making is everywhere, right? If you don't know about evidence-based practice, just go do some research on it. You'll be amazed how many disciplines require evidence-based practice, which is based in statistics and data. So there's information out there. This information can be things we observe, counts, measurements, responses, all kinds of things. Anything can be data. Now, not all data has a numeric property in its basic form. Many things will have non-numeric properties in their basic form, and we'll have to deal with how do we treat those. So we'll talk about that in a bit.